everyone, my colleagues Elorri, Paul, and myself are pleased to welcome you to the first webinar of the series Science to be Green. So You Think You're Green is the name of the series of 5 webinars. Thank you so much for having registered and being here tonight. Of course, we would have preferred to be there in person, but online is good too. For the next hour, we will go through the various questions you may have about the environmental impacts we cause through mobility and how we can make things better. So just a few practicalities here. It's a 1-hour presentation with live polls. And at the end, you will have a half an hour to ask questions. So there's a full question and answer session at the end. Do not hesitate to start asking questions in the chat during the lecture, or during the conference, or also to note them so that you can ask them at the end. So it's so that the question and answer session is the most efficient. It's a recorded webinar, and the video and the slides will be available shortly after. I should be changing slides now. Yeah, here we go. So first things first, I would like to introduce who we are, introduce our group, say a few things about what we do. So the Luxembourg Institute of Science Technology, or LIST, is a research and technology organization which focuses on 3 main topics: materials, information technology, and environment. And within the latter departments, so environment, the Lifecycle Sustainability Assessment Group works with assessing the environmental impacts of products, services, and activities. And we have clients a bit everywhere. We work for private companies, but also public services. Here are a few examples of people who have worked over the years. But today we're not here for that. Today we're here to have this public conference about climate and mobility. First, there will be a poll. If I can change the slides. Yeah, a live poll that starts now, if we can have it. Great. And the question is, have you heard of carbon footprint before? Please select one of the options. Yes, that's my job. Yes, I have tried to calculate mine. Yes, as a general term, or no, not at all. I will give you a bit of time, maybe 1 minute. Let's say 30 seconds. Okay, let's see the results, maybe. Okay, that's a very good and interesting answer. We have a very diverse public today. So a lot of you actually work in the carbon or with carbon footprints or in the environmental sector. Some of you have even tried to also calculate your carbon footprint, even if it's not your job, and as a general term. So it's quite pleasing to see here that no one here is not familiar with the term. But we will still go through the next slides to show you why it's important and how us as individuals and citizens will relate to climate change and global warming in general. So in our first section, I will introduce you to the notion of carbon footprint, in case you don't already know, which we saw was not really the case, but anyway. So this graph is taken from a recent IPCC, so Intergovernmental Panel on Climate Change report, and it shows the world CO2 emissions from 1870 accumulated on the x-axis here. So you have the unit here. And on the y-axis, you can see the observed and model warming of the atmosphere in degrees Celsius. And of course, as you may already know, there is a strong correlation between the two. As of today, we have emitted about 2.2 trillion tons of CO2, or 2,200 gigatons. The corresponding warming from pre-industrial time is about 1.3 degrees. That's about where we are today. If we do nothing, we might reach 4.5 degrees of warming at the end of the century. You have to know that at more than 4 degrees, significant consequences occur, such as more frequent and intense climatic events, sea rising, which will displace hundreds of millions of persons living on shores and deltas around the world. Even parts of the world will actually not be inhabitable anymore for a certain time in the year, as they will reach temperatures too high for us to self-regulate through sweating. So it's actually a very important question. It's a phenomenon with a lot of momentum and inertia, so it's important that everyone knows about it as soon as possible and that we make these efforts. With moderate efforts, let's say, we would end up at about 3 degrees, and with more, let's say, extreme efforts, we will actually be able to maintain our warming under 2 degrees. And that's important because that's actually the goal that we set with the Paris Agreement 5 years ago. Important to remember that in 5 years, we have actually emitted about 200 gigatons of CO2, which means we only have about 900 gigatons of CO2 remaining until we complete the budget that will lead us to 2 degrees. So why is it important for us, and what's our place in this big picture? So before we continue with carbon, I have to say something, that carbon is not the only greenhouse gas, obviously, or you may not know, but there are other important ones. We'll go through them right now, and we won't really go much about it afterwards. So we mentioned that we emit about 40 gigatons of CO2 per year, and there are other greenhouse gases that add to that. Of them, there's fluorinated gases, which are mostly used in refrigeration, and they are very powerful greenhouse gases. They are used for the high ability to carry heat, to trap heat, but if they leak in the air, of course, they are still as powerful in the atmosphere than in your fridge. So that's actually quite powerful, even though they are not that much in terms of volume that are emitted. And the rest is nitrogen monoxide, N2O, and CH4, methane, which are mostly linked to the agriculture sector. So we'll see mostly about them in the lecture about food and agriculture. And importantly, we can quantify their heating potential in terms of CO2 equivalent, which makes it possible to sum them together and to actually have one score for all the greenhouse gases we emit. The reference unit, of course, is CO2, because that's the one we care about, and that's the one that remains the longest in the atmosphere. And so CO2 emissions have various origins. The most ancient of them is actually land use change. We have started emitting CO2 as soon as we started deforesting, because we changed the carbon stock of the land. And that's actually one of the most stable over time. That's the one in green right here. In yellow, you can also see process emissions from the chemical industry or the cement industry, for example, that have CO2 as an off gas of processes. And then the, let's say, infamous trio of fossil fuels, such as coal, gas, and oil. But of course, we don't consume directly this coal, gas, and oil. I don't have a storage of coal, gas, and oil in my house. And it's because they are first refined into fuels that are used by the economy. So that should be, yeah. And these fuels are actually used as energy carriers for different machines and devices we use. So they are used as fuels, of course, but also as heat or electricity. And these carriers are useful for us because they are then transformed into mechanical energy or kinetic energy or anything that helps us use the various devices and machines and all our industry to satisfy our final services, the final services we use. So in these machines, you have, for example, cars, airplanes, but also all the steel making furnaces and all that. And that's part of the big landscape of energy flows. It's quite complex, as you can see, but it's possible to connect them to end-use sectors. And these end-use sectors are mostly services such as mobility, freight, warmth, consumption of different goods, construction, and food, and also a bit waste. So all in all, we're able to connect the CO2 emissions and other greenhouse gases that you see on the right here to us, to what we use as citizens and in our daily lives. So that's exactly the exercise we will do just after, but first I have to ask you a question because it's a session on mobility. And the question is, if it works. So the next slide, Paul, now. The question is, how much mobility contributes? How much do you think mobility contributes to the carbon footprint of an average Luxembourg resident? So if you account for all the greenhouse gas emissions that could be allocated to our use or daily lives, how much mobility would be? So is it 12%, 30%, 54%, or 76%? Let's do another 20 seconds. So bear in mind that the picture we saw was for the world, and I'm asking you now for Luxembourg. Okay, I think we can move on. Let's see the results. Okay, so most of you answered 30%, and that's a very good guess. We'll see whether that's the actual answer afterwards. Very few answered 76, yeah. So, and also half would be a bit much, right? So 54% would be a bit high. Okay, that's a very good guess, and I'm glad that we have an audience of knowledgeable people. So let's go to the next slide now and see whether or how close the answers were. Let's continue. I'll share the rest with you. So this is the carbon footprint we're talking about. So everyone should see now the transport contribution. I just wanted to say that train and bus are small for two reasons, because they are really efficient ways to travel around. Of course, it's per kilometer, you will share the emissions with a lot of other persons. So if you can manage to fill a train or a bus, it's actually one of the best options. And of course, per person, then it appears as a very small slice. And it's also because in Luxembourg, we probably don't use public transport enough. A lot of people still prefer to use the car, and you can see the difference it makes in terms of carbon emissions. Of course, there's a lot of other sources, or at least sectors to which we allocate greenhouse gas emissions, which is housing, consumption goods, food, and services. Services is all the public services and health, so hospitals, schools, even the police should be in there. So it's everything that the government does for you. And all of that is allocated to you, and that's about 13 tons for Luxembourg. So the question is, how big is that? Well, it's clearly on the top of countries globally, typical for a rich country. But a more important question is it too much? To which the answer is also clearly yes. So for the global population to live sustainably in 2050, we should reduce this number to 2 tons, which is about the size of the box. And now I will let you think about the different ways you think you could put all this other colored box into the 2-ton budget. And at this point, you should have already a few questions. So I know about my carbon footprints. I know that flying is one part of it, so we will leave the floor just after to Paul to talk about this. What about commuting options? Now, 2020 has been a year where we ask these questions typically. And then if you absolutely need a car, should you go electric, and is that really better? So I will leave Paul the floor. I will also share my keyboard with you, Paul, so that you can change the slides.
Great.
Here you go.
Thank you, Thomas. So now we have a good overview of the carbon footprint of a Luxembourgish resident. And one thing that surprised me when I looked at this carbon footprint is that plane travel actually accounts for quite a large share of the emissions that can be attributed to our mobility demand. So 1.2 tons roughly for an average Luxembourgish resident. So maybe one question, if we dare again to make another poll, is how much did you actually travel by plane last year? So taking 2019 as a reference, and taking into account both business travels and personal travels. So maybe we can try to have another poll, and then we see whether it's never, once or twice, 3 to 5 times, or even more than 6 times. And we ask about round trips, so not individual flights. Maybe a couple more seconds, and then we can move on. Okay, I think we can close the poll, and then we'll see if we have some big or some small travelers among us. Okay, so 15% of people never fly, which is quite good. I hope they took 2019 as a reference, because in 2020 I managed to not fly at all as well. And then we see also some people who travel quite a lot. So let's see where and how traveling by plane is actually detrimental to the climate, and why flying accounts for such a substantial share of our mobility-related emissions. Because I take the car not every day, but certainly quite often, and it only accounts for a bit of that mobility-related emissions. So let's try to dissect this. And of course, the largest contributor is the direct emissions that occur when taking the airplane. So the consumption of the kerosene, which is then burned, and the CO2 mainly, which is emitted through the engines. And if you look at the bottom left of the screen, what we did here is we actually looked at values for long distance and short distance flights. And this also gives me the opportunity to introduce a bit the units that we will use throughout of this presentation. So the first part of the unit that we present here is the kerosene consumption per 100 kilometers, which I think is fairly well known. This you often use as well to measure the fuel consumption of cars. But then what we do on top of that is we look at how much we actually consume per passenger. This might not be as relevant for cars. We will see later that it can be, but it's mostly relevant if you compare different transport modes, such as planes for long distance flights, planes for short distance flights, but also buses and trains and so forth. So in this presentation, throughout this presentation, you will see this unit, which we will denote as PKM, passenger kilometers. And one reason why short distance flights, as you can see here, per distance and per passenger consumes more kerosene is because short distance flights, the takeoff and the landing phase will contribute more to the mean than for long distance flights, for which the flight at cruising altitude is more relevant. And that's why the mean values here are a bit different, and why short distance flights have higher consumption. So next, another quite important contributor is the fuel life cycle. So the extraction of the crude oil, the refinement of that oil, provision by transport to the airport. And also the construction of the infrastructure, so construction of the plane, construction of the airport. And all of this together is what we will usually refer to as the life cycle. We didn't look here at the end of life, so the waste treatment. And this is what we base our comparison on. So next, what I will do is I will present to you the comparison between long and short distance flights, taking into account these different sources of greenhouse gas emissions. And first, we look at the infrastructure, where long-distance flights have a bit higher contribution. Then we look at the fuel life cycle, and we look at the direct emissions. And as you can see, for short-distance flights, if we take the per passenger kilometer comparison, you can see that they actually have slightly higher emissions. And usually for most other transport modes, these are the most relevant emissions that we will look at. But when you take the airplane, there's actually something else which causes the airplane to be so detrimental to the climate compared to other transport modes. And those are other emissions which occur at these high altitudes. This is, for instance, nitrogen oxides, so NO, NO2, which cause the formation of ozone, another greenhouse gas, at the upper troposphere. We have the formation of contrails, condensation trails. So these are the white lines you see in the sky, which cause the reflection of some of the incoming sunlight, but also reflect back some of the radiation coming from the Earth back to the Earth. And their net effect is that they also contribute to climate change. You have water vapor, so some of the water that is emitted ends up in the condensation trails. Some of the water increases the concentration of water vapor, which also acts as a contributor to climate change. And finally, you have aerosols, which I think we have heard a bit about in the last months, but here we talk about little fine particles which are emitted like soot and which are suspended in air, and which also have some effect on incoming and outgoing radiation. Now, what is the net effect of all of these other emissions combined? Well, the honest answer is that we don't know exactly, but the studies that we looked at suggest that this can be as much as the emissions caused by burning of the kerosene, up to 3 times as much. So this is quite a lot, and this is one of the explanations why taking the plane is quite detrimental to the climate. So yeah, these are the figures that we found, and let's just look at a few decisions that you might be faced when you travel on a daily basis long distance. So what we did here is we took into account a bit the electricity mixes of different countries, and we tried to compare taking the plane against taking the train. And as you can see here, for instance, if you go from Luxembourg to Amsterdam, your per passenger emissions by plane are around 5 times as high as if you take the train. And this is something that you consistently see. So this is not just for one city, but for any city that you would travel from Luxembourg, you would see that the train is just much more efficient in terms of CO2 emissions than the plane. Now you see some variations here of the train emissions, like between a travel to Berlin and a travel to Bordeaux, where you see that different electricity mixes can influence the emissions of a train a bit. Taking the train to Bordeaux, you take the French electricity mix, which is high on nuclear energy, having a bit lower CO2 emissions per kilowatt hour. If you go to Berlin, there's a bit more of coal in the energy mix, so the emissions will be a bit higher. Now, if you would take the train for all of these trips, imagine those are the trips that you will take next year. If you consistently take the train, you will see that you can reduce the CO2 equivalent emissions quite a bit, by around 80% is what we estimate. But of course, it's difficult to always take the train because we also estimate that it will take you roughly twice as long. And sometimes business trips, they can be quite constraining and you have to take the plane. But you can see that here the train is quite a bit more efficient than taking the plane. But those are the long distance travels that you take. So next, Elorri will look at a bit more of the short distance travels, your everyday commuting.
Yes, indeed. So now we will focus on commuting impacts. So I know that probably most of you are staying home now, but we will start with a new life pulse to know a bit your habits in terms of commuting. So, of course, you can consider your habits before the pandemic situation. So what is your main transportation mode to commute? So you can select either walking or cycling, motorcycling, driving your own car, carpooling, or public transport. So either the train, the bus, the tram, any public transport. So we can wait a bit for you to have time to answer, and everybody can be counted in the results. So this is just to know a bit more about you and your habits, a bit like for the plane. And we wait a few seconds. So when we are ready, we can show the results. Okay, so most of you are taking your car, so alone, I guess, so the half of you. But a significant share is also taking the public transport, 42%. And yeah, a minority is an active commuter by walking or cycling. Good, so now that we know what are your habits, let's see the impact of these transportation modes. So we can go back to the presentation and see the figures. Okay, so now in this figure, we have displayed the carbon footprint of different transportation modes. So not all of them for simplicity. For example, for the car, we will see later other types of car like hybrid car or gasoline car. The numbers, they consider all the greenhouse gas emissions that are emitted through the different steps that are required to finally move from point A to point B. So, for example, you need to produce the bike, you need to produce the car, the infrastructure of the train, you need to produce the electricity, the diesel, etc. So it considers really all the greenhouse gas emissions, like for the plane results. And we express the results with the same unit, which is gram of CO2 equivalent per person per kilometer, or per passenger per kilometer. In the bottom of the figure, we see that the best way is to walk. So there is no carbon footprint, no impact, because you don't need anything to walk. Then comes the bike. It's a really low impact mode because you only need to buy the bike and dispose it, but then you don't need any fuel to run the bike. For an electric bike, the impact is a bit higher because it's also a bit heavier and you need to supply with the electricity to run it. Now, if we move to fossil fuel-based transport, like the motorcycle or the diesel car, the carbon footprint is significantly increased because, as we have seen before, the CO2 emissions today are mostly due to the use of fossil fuels. And the highest figure in this graph is the figure for the diesel car, where there is only one person, so the driver, with a number of 236 grams of CO2 equivalent per person per kilometer. This value is representative for a medium-sized car in Europe. It's taken from the report for the European Commission. So you see the reference on the right of Hill and colleagues in 2020. But of course, this value can vary a lot. So for example, depending on the size of the car or the driving behaviors, we will see that later. This is just an average for Europe. And then if we are several persons in the car, as we are sharing the cost when we do car sharing, we can also share our carbon footprint. So if you are 2 persons, so it's the 2P on the left, you can divide the carbon footprint by 2. So it's 118 grams of CO2 equivalent per person per kilometer. So we can see that car sharing is a very good option to decrease our driving impact. So we need to and be alone in our own car. If we switch to an electric car with the same number of persons in the car, compared to a diesel car, we can reduce by more than 40% the carbon footprint. So with one single person, the value is equal to 131 grams of CO2 equivalent per kilometer. And again, this value comes from the same report for the European Commission. So it's based on the medium-sized car with the average electricity mix in Europe. We will see later the influence of using the different electricity mix in European countries. But this lower value is due to the fact that electricity is not only supplied with fossil fuels, so it's better than a diesel car. Now, if we go to public transport on the top of the figure, we have the diesel bus and an electric regional train. And we have some percentage here that represent the occupation rate. So we didn't put the number of persons like for the car, but to simplify, we put the occupation rate in percentages. And on average, the occupation rate of a city bus or a regional train is a bit below 20%, so it's quite low. But even with this mean value, we observe that the carbon footprint of a diesel bus is 94 grams of CO2 equivalent per person per kilometer, and 76 for the train. So with this value, we see that it's beneficial to take public transport compared to driving your car alone. Of course, if the bus or the train is almost empty, the carbon footprint will increase. You can imagine that a bus consumes much more than a car, so it's about 40 liters per 100 kilometers. So of course, we need a sufficient number of persons in the bus to have a low carbon footprint compared to a car. On the contrary, if the bus or the train is full, so it's the 100% value on the graph, we have a very low carbon footprint, so about 13 grams of CO2 equivalent per person per kilometer for the train and 16 for the bus. These values are very similar to the bike value, so we clearly see that taking public transport is a good option to decrease our carbon footprint. And we need to use the existing lines for two reasons: to increase the occupation rate, which will decrease the carbon footprint per passenger, and also to avoid to add an additional transport in the system, especially if it's a car. So now, yes, let's talk about teleworking. So I guess that most of you have experienced teleworking this year, and generally it's seen as a good option to reduce our environmental impacts. And it's true that mechanically, we will avoid the commuting impacts we just described before. But the question is a bit more complex than this, because there are direct and indirect effects that depend on several factors, and there are pros and cons that we will detail now. So on the pro side, we can also optimize the impacts of our offices. So for example, if we can reduce the number of square meters per person or decrease the energy used in our offices, it will decrease also the impacts. But it will depend on the factor. For example, if you are working in an open office, the fact that there are less persons will not really decrease the energy of the office. On the other side, you will probably use more energy at your house. And again, it depends on several factors. So the number of persons living in the house, the type of house, and your behaviors in your house. You will also probably use more ICT tools, and in particular, the video conferencing tool that has an impact because you need energy to store and exchange data via the internet. Maybe you will do other travels than commuting when you are staying home. So for example, if you are used to do some activities on the way to work, like shopping or driving your kids at school, then you will still to do this travel when you are staying home. But maybe you have new behaviors that are more eco-friendly. For example, if this other travel I just mentioned, they are closer to your house, you can probably do it by walking or taking public transport. If you are more used to video conferencing, maybe you will avoid more business trips in the future. So these are positive effects of teleworking. But on the other side, I also put here commuting, so it can be a bit surprising to see commuting on the bad side. And in fact, some studies observed that teleworkers were doing more kilometers to commute per week than non-teleworkers. And the possible explanation is that if you are doing the commuting trip less often per week, you would consider to live more far away from your work to have maybe a bigger house and a cheaper house. So you will do more kilometers, but only 2 or 3 times a week. So this is a bit of qualitative analysis, and let's see what it means in terms of number with a simple example. So a person that do 2 days teleworking a week, and the person needs to commute for 15 kilometers with a car, but every day the person still needs to drive the kids at school for 5 kilometers, also with the car. So we can avoid the emission of 610 kilograms of CO2 equivalent per year, so it's quite a significant amount. But here we consider only a few effects, so the fact that we need energy at the house, the ICT, and the other travels for the school. Overall, it leads to a benefit of 360 kilograms of CO2 equivalent per year, so it's good and it's not negligible. But let's see just the effect of a simple decision. So if the person considers that because she or he is doing teleworking, they can move to a bigger and cheaper house 20 kilometers more far away from the work, then this will lead to an additional impact of 860 kilograms CO2 equivalent per year. So in conclusion, most of the study that looked at the impacts of teleworking concluded that this should be an environmental, this should lead to environmental benefits. But they also acknowledge the fact that they do not consider all the direct and indirect effects because of the complexity and their dependence on individual behaviors. So let's do teleworking, but still be aware of our behavior when we are staying home. And now I will let the floor to Thomas to compare the impacts of some cars.
Thank you, Elorri, for this interesting analysis of commuting and home office. So I think you understand now why it's important to think in systemic life cycle terms when we compare various options. And this is exactly what we will do in the next slides to compare various options for cars. So if you absolutely need a car for your daily life, then you're probably wondering which kind is best. And an increasing number of countries, actually also jurisdictions, are planning on phasing out internal combustion engine cars, which are diesel or gasoline. But what are the alternatives? So how much better are these alternatives, and how do they actually compare to the conventional cars? So this is what we'll see in the next slides. So first things first, what are we comparing exactly? So Paul already introduced us to the notion of life cycle. Here we will be looking at life cycle greenhouse gas emissions of driving over 1 kilometer with one vehicle. So it will be per vehicle kilometer. The options we compare are diesel, gasoline, battery electric, plug-in hybrid, gasoline, and fuel cell hydrogen. For comparison, I know there's not so many in Luxembourg. So what does the life cycle include? First, the life cycle of the car itself would be an important part. So here we have the emissions of grams CO2 equivalent per vehicle kilometer for production, maintenance, and end of life of the car body itself. Then comes the extraction, refining, transportation, and distribution of the fuels. So with here electricity in hatched. So liquid fuels in light blue, also including hydrogen at the bottom, as you can see. And hatched for the electricity. So for example, you see that plug-in hybrid cars use both here. And finally, the one you're probably the most familiar with, because that's the one the manufacturers give you when you buy a car, is the direct emissions of greenhouse gases. So in total, you see that diesel and gasoline cars emit the most CO2. But until you actually account for the direct emissions, the other cars were actually more emitting. So it's actually quite interesting because it illustrates the trade-off between indirect and direct emissions that usually occurs with the new alternatives. And it's true for a lot of technologies, actually, not only for cars. And it's also what has led to so many debates to know if electric cars are actually better or not than their fuel alternatives. So if you're interested, you can also look at our T-Mobile tool. We put the link here for when you have the slides, but you can click and go and compare yourself different cars, making different assumptions, and see in which cases the electric cars are better or not than the internal combustion engine cars. So everything we talked about now was CO2. So we find again this value of 236 grams, which is our average in Europe for a medium-sized diesel car. Gasoline is a bit higher. And then you also have all the alternatives. So battery electric with the European electricity will actually be quite good in comparison. So you would halve your emissions from a gasoline car just by driving an electric car in Europe. A bit more for plug-in hybrid because you still have all the life cycle of the fuel. So you have the extraction, distribution, and burning it in the engine. And finally, fuel cell is still high because today hydrogen is made from methane, which is a greenhouse gas and still emits CO2 when you crack the methane to get the hydrogen out of it. And there's other options to do it. You can produce it from electricity, and water, which is called electrolysis, but then it becomes as carbon intensive as the electricity you use to produce that hydrogen. So it's kind of displacing the problem. But hydrogen is still useful for other applications. So how can I decrease this carbon footprint from driving? We have another nice tool in Luxembourg called carboncounter.lu. So it's easier to find. You can look at it after the conference, which gives us, for a set of cars that are commonly available in Luxembourg, here on the x-axis, the curb weight, so the mass of the car, and on the y-axis, the greenhouse gas emissions on the life cycle. And it's actually quite interesting. You see the different groups here of gasoline, diesel, hybrid, plug-in hybrid, and battery electric vehicle. And of course, it's probably obvious for a lot of you, but the emissions actually correlate very well with the mass of the car, with the weight of the car. Because to move more weight, you need more energy, and to have more energy available, you will emit more CO2. It's true for the use phase, but it's also true for the production phase. To make more materials linearly, you will have more emissions. So even before we talk about the different motorization options here, or powertrains, buying a smaller car will always reduce your carbon footprint. So these are the different cars that are actually in the tool. And you see that the basic conclusion before we even look at the colors is that driving a smaller car will always be a better option. And it's also important because when you buy a car, it's usually for a few years. So you will actually be locking yourself into a mode of consumption that's energy intensive if you buy a big car. And it's actually much better if you the car is smaller. And then you can try, when you use it, to avoid accessories. It's actually very high on consumption. That includes trailers, roof boxes, but also roof bars are quite bad on consumption, as you may have experienced before. There's something else you can do if you cannot change your car. It's eco-driving. Eco-driving is anticipating on the road. It's slowly accelerating and slowly braking. So braking is actually losing momentum in heat. So you're converting your kinetic energy into heat, which is the worst you can do in terms of energy conservation. And you can cut up to 20% of your consumption. And additional note, let's see. Yeah, so the energy consumption inside the car, in the cockpit, is also important. If you live in a country with a terrible winter, or the opposite, with a terrible summer, you will use AC or heating, and that actually amounts for a few % of the consumption. Last thing we wanted to say for plug-in hybrid cars is that there's this new study that came out 2 months ago that was actually a survey on the use modes of hybrid cars. And we see here that a lot of the plug-in hybrid cars, if not all of them, actually show higher consumptions of fuel compared to what they were advertised for. And that's basically because people forget to plug them. So big advice here, or big interpretation of the studies, is that if you have a plug-in hybrid car, you should use it as a fully electric car and plug it as much as you can, charge it electrically as much as you can. Otherwise, you just end up having a gasoline car that's just carrying a battery around. So if you have a plug-in car, this is actually pretty important to charge it as much as you can. And especially in companies, as this study shows, which are the ones that forget the most to plug the cars. Right, but now we've mainly talked about CO2. And as you may know, and as you may have read and seen, there are criticism of electric and hydrogen vehicles regarding resource consumption. So doing the same analysis from the same phases of the life cycle, we can, for example, start comparing our different powertrains compared with regard to fossil resources. And we see that, of course, commonly diesel and gasoline use a lot of fossil resources, not so much for production, but mostly for the use phase. But of course, electric, hybrid, and fuel cell hydrogen cars also use fossil fuels. Either because we make electricity still from a lot of fossil fuels around, but also because hydrogen, as I said, right now is still made of fossil fuels. So you can see that if you account for all the primary energy and all the fossil resources extracted from the ground to the kilometer you drive, a fuel cell hydrogen car will actually perform a bit worse than a diesel car. So in this case, at least for today, it's still the case. And something else that has actually been the topic of a lot of articles and discussions is the metal and mineral resources. So of course, as you may know now, that electric and hybrid cars, also fuel cell electric cars, have a higher consumption of resources, and mostly, for example, copper. You have 3 times as much copper in an electric car than in a regular car, and more exotic materials such as lithium and platinum. You have about 5 to 7 kilos of lithium in a battery for an electric car, and you have platinum in a fuel cell of a hydrogen vehicle. And these are, let's say, materials for which we don't have much overview on the supply chain. So far, we actually don't know in life cycle assessment really how to assess. There's no consensus on the criticality assessment of materials. It's something to remember about. And here we see battery electric vehicles are use the most minerals and metals. Another aspect of life cycle assessment, air emissions. Carbon monoxide emissions are actually higher for gasoline engines, which have typically incomplete combustion and will emit CO, which is not really an issue in open air, but if you're in a closed environment, such as a parking lot or a garage, you will have, you may have headache problems, and yeah, but it's also common sense not to let an engine run in a closed environment, just to show that you also have trade-offs across powertrains. And one we talked about, nitrogen oxide emissions. We talked about it with smog, so it's causing this thick fog, or smog it's called, yeah. Usually in summer, in big cities, you may have seen it yourself. And here, diesel is the one that emits the most of the precursor of that, which is nitrogen oxide, as we will see a bit more in the next slide. So I'll spend another slide on the issue here. So there's usually been a big question. So before we had even the question about electric cars, the debate was whether diesel or gasoline was more impacting. It's just because diesel and gasoline emit a lot of other things during their use phase than CO2. So they emit NOx, SO2, sulfur dioxide, and also particulate matter, fine ones at 2.5 micrometers here. And at least NOx and SO2 generate the formation of ozone, which also affects human health via inhalation, respiratory diseases due to alveolar irritation in your lungs. But they also affect ecosystems due to soil acidification, for example. So mainly SO2 will cause that. And for that, the various Euro norms that you may be familiar with, the Euro 3 came out in 2000, Euro 6 came out in 2014. So there are gradual, more and more, let's say, stricter and stricter regulations on the amount of NOx that are emitted per kilometer for both diesel and gasoline. Diesel is higher because mechanically, due to the nature of the combustion, you have more NOx per kilometer. But what we've seen is that there is a lot of non-official, or let's say excess NOx that came from diesel engines for private vehicles. And this excess NOx, due to the causes I've described just before, have been shown to cause about 11,000 premature deaths in the EU due to the on-road NOx excess. So just because of surpassing the legal limit threshold. And that's about 65% more of the emissions. So that's actually a huge surplus of emissions that are not even authorized. So that's good for me. I think we will now switch to electricity supply with Paul, because we talked about electricity and how it is used for electric cars, and we also mentioned that our average was for Europe, which means there's probably variations across the countries.
Exactly. Thank you, Thomas. So I think many of you have already asked yourself this question during the presentation. What about these different electricity supplies? We have talked about it a bit earlier when I talked about trains, but Yeah, maybe to ask you a question. In how many of the European countries, so taking the EU28 still, in how many of these countries do you think that taking an electric vehicle is actually worse than driving a gasoline vehicle? So more specifically, in how many of these countries is the electricity mix so CO2 intensive that it will cause the life cycle emissions for an electric vehicle to be higher than those of a gasoline vehicle? So we will let you a bit more of time to answer this question. Is it 1 to 3, 4 to 7, or more like half of them? Okay, I think that should be enough time. Maybe we can move on to the answers. Okay, that's quite interesting. So 18% think it's 0 to 3, and then roughly a third think it's 4 to 7 or 8 to 11, and then 15% think that it's up to a half of the EU28. Okay, so let's see if I can answer this question adequately in the following slide. And this will be quite a complex one. So let's see. So first, I'm showing here the reference, and these figures you have already seen throughout of this presentation. So here on the left side, you can again see the CO2 equivalent emissions per vehicle kilometer. And then here in the first column, you see the emissions of the reference, which is a gasoline vehicle, which, taking into account all the life cycle emissions, will emit around 270 grams of CO2 equivalent per vehicle kilometer, and we will refer to this as the reference of 100%. And then in the second column, you can see diesel vehicles, which will emit around 230 grams of CO2 equivalent per vehicle kilometer, or 85% of the reference. And the third column will show you what you have already seen before. So these are the 131 grams of CO2 equivalent per vehicle kilometer, or 45% of the reference, taking the average electricity mix in the European Union. And what I will show you next is the scores for the 28 European countries, so still taking into account the UK. And what you immediately see is that for all of these countries, there's quite some variability in terms of their CO2 emissions, which reflects the variability in the electricity mixes that exist in these countries. And the answer to the question is basically how many of these bars are higher than 100%. So for how many of these bars is that the case? Well, it's basically only the first country, which is Estonia. And the reason for this is that in Estonia, you have quite a high share of crude oil in the electricity mix, which is a relatively CO2 intensive source of energy. And for all of the other countries, we can see that the scores are lower than the reference. And here you can see the percentages to estimate how much lower they are. And I will not go through the 28 European countries right now. I will just highlight maybe a few. So maybe the neighboring countries to Luxembourg, which are Germany, which have quite a high share of coal in their electricity mix, and that's why they are towards the left of this graph, with around 170 grams of CO2 equivalent per vehicle kilometer, or 60% of the reference. If we move towards the right of the graph, we come to Luxembourg. So Luxembourg, of course, imports some electricity from Germany, some from France. It will end up a bit in the middle. And you see that here we are roughly at the average European emission rate, so around 44% of the reference, or 130 grams CO2 equivalent. Our neighbors in Belgium have a bit cleaner electricity mix than us, so around 38%. And finally, towards the right of this graph, you see France and Sweden, which are the two European countries which have the lowest emissions per vehicle kilometer in Europe. And for both of these countries, this is because in both of these countries, you have quite a high share of nuclear energy in the electricity mix. And for Sweden, on top of this, you have quite a high share of hydro energy in the mix, which causes them to be I think the only two countries for which electric vehicles emit even less than 100 grams per vehicle kilometer. So this gives you a nice overview of both the variability that exists, but also that quite consistently, with a few exceptions, electric vehicles actually perform, at least in our estimation, a bit better than internal combustion engine vehicles. So next, we will try to digest a bit all the numbers we have thrown at you, and this will be done by Elorri.
Yes, indeed. We provided you a lot of information, and now we will process it and give you takeaway messages. So in the beginning of this presentation, we show that on average in Luxembourg, we have a carbon footprint due to mobility of 3.9 tons of CO2 equivalent per inhabitant. So this is a high number, which was based on statistics in Luxembourg. For example, on average in Luxembourg, there is 0.7 car per inhabitant, and there is an occupation rate of 1.2% in the car. So it's quite a low occupation rate. It means that 80% of the time you're alone in your car driving. And the driving distance per year is 15,000 kilometers. So this is above the European average, which is 12,000 kilometers a year. Then we took some data for the year 2019, of course, for the flights, based on the data from the airport of Luxembourg in terms of the top 10 destinations, which are all in Europe, and the number of passengers. So we estimated that on average, we travel almost 5,000 kilometers a year with the plane in Luxembourg. And this is in Europe between 1 and 4 round trips, depending on where you go in Europe. And then a distance of 1,200 kilometers per year with the public transport. So how can we reduce this 3.9 ton of CO2 equivalent? So we did some profiles. The first profile is a conscious driver. So if you have a car, you already start with a disadvantage, because compared to the average, which has in theory 0.7 car, you are worse than that. But you can try to compensate this impact by adopting, for example, eco-driving behavior, so to limit the fuel consumption of your car by, for example, 10%. You can also promote car sharing. So if you have an occupation rate of 2% per car, this is the example we took. And you can also try to decrease the distance you travel, for example, by teleworking. So if teleworking allows you to save 1/3 of your yearly distance, you can reach maybe 10,000 kilometers instead of 15. If we take these assumptions and we keep the others similar, then we reach a carbon footprint of 3.5 tons of CO2 equivalent. So we see a decrease compared to the average, but it's a small decrease. So let's see some other profile. We took the profile of a small traveler, so someone who does not like much to travel. And because he doesn't drive much, he also can afford an electric car, and he will, or she will do 5,000 kilometers with this electric car. The person will only do one round trip with the plane in Europe. So, for example, a distance of 1,300 kilometers, and about 3,000 kilometers with the public transport, so a bit more than the average. And in total, we can have an impact of 2.2 tons of CO2 equivalent per year. So this is almost half the value for the Luxembourgish average. So it's a really good option to decrease your traveling distance, in particular with the car and with the plane. And if you can also switch from diesel or gasoline to electric car, you can have a further reduction of your impacts. Now we took an extreme case, someone does not have a car and does not travel by plane, but he likes to travel anyway. So either to commute or for holidays. On average in the year, the person will do 15,000 kilometers a year with the public transport. And in that case, we calculated a value of 1.5 ton of CO2 equivalent per year. So this is a very small value compared to the average. Maybe it's not enough to reach the Paris Agreement target of 2 tons CO2 equivalent per year for 2050, because it will mean that all the other activity will only emit 0.5 tons, but still it's a very low value compared to the average. And the final profile we simulated, it's the urban flyer. So for this one, we consider a person who lives in a city. So he or she does not have a car and use the public transport, but in a lesser extent, so 3,000 kilometers a year, because he lives close or she lives close to the work. But then for holidays, this person likes to travel far away. So making, for example, a transatlantic flight or going to Asia. So with only 2 international flights, this person could emit like 6.6 tons of CO2 equivalent. So the message here is you can do efforts through the year, so by not driving or limiting your travels. But if for holidays you do a very long travel by plane, you can fully compensate this advantage and this effort you make through the year. So let's conclude now. So we have seen that transport is a major contributor to our carbon footprint, so about 30%. But the good thing is that we can do something about it. We can decrease this value. For example, one option is to switch our displacement of driving or flying by public transport, and this will have a significant impact. So more than 50% reduction if we do for all of our displacement, and it will be lower, of course, if we only switch for some of our travels. Then we have seen that teleworking is also a good option to reduce our environmental impacts, but we also observe that it could have rebound effects, so the fact that our behaviors at home could compensate the benefits of the avoided commuting. Then we talked a lot about electromobility, and we have seen that the use of electric vehicles could decrease the carbon footprint of driving in almost every European countries. But there are some trade-offs. So in particular, we saw that electric vehicles need more scarce materials than gasoline and diesel cars. So there are still many challenges to really consider electric vehicles as a sustainable option. And for example, we need to reach the energy transition to have low impacts for electricity and to have a sustainable extraction of resources. So I hope you enjoy this presentation. And I think that now we can open the Q&A session. So thank you very much. So now some of you already asked some questions in the chat. So just to answer one practical question, as Thomas said in the beginning, the presentation and the video will be available after this event, so maybe tomorrow. So don't worry, you will have all the figures and the references. So now we can maybe start in the order. So don't hesitate to write your question. So the first question is asked by Etienne Jacques. Does the tank tourism not impact the Lux footprint significantly? So maybe Thomas, since you present the carbon footprint of Luxembourg, you can answer this.
Yeah, thank you. It's a very good question. The reason so for those who don't know, I don't know if everyone knows the case in Luxembourg much, but it's a small country and a lot of people actually cross the border to come and fill their tank. It's either individuals or most likely big trucks that actually do long distance freight over Europe that stop in Luxembourg, refill the tank and continue. And in statistics, at least in national statistics, that's usually allocated to Luxembourg and to the use of fossil fuels in Luxembourg. What we've done in this exercise is the opposite. So instead of using this top-down approach of actually calculating all the fuel that's actually used in Luxembourg and then divided by the number of people, we actually started from the person and then calculated how many kilometers that person traveled over a car, plane, as you saw. And so with that, we're able to adjust for this statistical anomaly. So fuel tourism would not be accounted in this picture. Yeah, so that's also why there's a lot of discrepancies between the announced carbon footprint in total, which I think is about 16 to 17 tons or even more if you use the top-down approach. But if you use the bottom-up approach, you're about at 13 tons.
Good.
I hope that
So
answers
it's
the question.
pity we cannot interact more. So if you are not satisfied or if you want clarification, just put it in the chat and we will come back to this answer.
If anyone else has remarks about this, please contribute to the chat.
Yes, unfortunately, the chat is the only option now to interact. So I will take one question about the teleworking. So Guido Bosch said, personally, I don't agree on the results of the commuting study. Since the confinement, I live 3 times further from work, 100 kilometers versus 35 kilometers, but I have driven only 600 kilometers versus 14,000 kilometers in normal times. So indeed, the comments, the slide we had on teleworking was not about teleworking during confinement. It was about teleworking as a normal, as an option in a normal times, let's say. So in a confinement period, we all reduce our mobility and the impacts associated to transport, and this is why we reach about 5 or 6% of greenhouse gas emission reduction worldwide. But this is not due to teleworking. This is due to the confinement. So the results we detailed about teleworking and the qualitative approach was about teleworking implemented in a company, but not in a confined society. So this is just a comment. Of course, confinement reduced a lot the transport impacts. So there is a question now, maybe about the bus. So Gil Kirchen asked, doesn't the bus drive anyway? I know that it's normally a strawman argument, but the bus has strictly defined schedules. Was this considered? Thank you. So I don't know if, Paul, you want to answer just to change, or you want to...
Maybe I can answer a bit, and then maybe the others can complement. So the first part of the question is, of course, true. The bus will drive whether you take it or not. Not sure how long it will drive if no one takes it. I think at some points bus lines are always being cancelled if no one takes them. But I think to answer the question, you have to think about the research question that you ask yourself. Whether you're thinking about one individual choice or whether you're thinking about the transport system as a whole. If you want to compare different transport systems, you of course have to take into account the bus, whether it's empty or not. But when you look at the individual choices, maybe you're a bit less concerned with whether the bus drives, but you're more concerned with just evaluating your options. Maybe the others have additional perspectives on this. With the last part of the question, was this considered? I'm not quite sure to which figure this refers to, so this is maybe something we have to...
Maybe the fact that when you are driving, there is a bus that also drives anyway, because there is a bus that does the same trip as you are doing with the car. So this is not considered. In fact, it's what we are showing is only the carbon footprint of individual transportation mode per kilometer. But of course, there are systemic effects, but we didn't show this. So the fact that the bus are driven anyway, and the fact that if you take the car, maybe you could attribute yourself the impacts of the bus and the car, but no, this is not the standards in our carbon footprint calculation. So I hope that we answer this question. Maybe Thomas, maybe you can answer the question about the projection for 2030. So there is Cassandra Francis who asked, hello, on slide 26, maybe we can go back to it. There is a projection for 2030 that is quite dramatic for electric cars. Can you explain why that is?
So as you may know, the European Union has a strong, the European Commission at least has a strong will to reduce our carbon emissions. And one of the most efficient ways to do that is to decarbonize electricity production. And that's exactly what you see here. So a share of that reduction is actually making cars more efficient. So per megajoule of energy they use, they would actually drive a little more in terms of kilometer. But most importantly is the CO2 content of electricity. And most of the countries have a plan to get rid of fossil fuels. So to get rid of CO2 intensive electricity generation and to go towards more renewables. So different countries have different strategies, but overall, it's mainly to have more and more photovoltaics, wind power, hydropower, and also biomass in the electricity mix to replace coal typically. And so that's the reason of this dramatic decrease for most of them. Of course, if you start from very high, it's also easy to be dramatic and to actually halve your emissions. If you're already really low, the reduction wouldn't be that high. But it's true that for some countries, you would even reduce to the point where production only would be emitting in 2020. So for example, the life cycle emissions of an electric car in Austria would be at the same level as just the production of the car. And that's also because upstream, so when you produce a battery, typically, you also use a lot of electricity. And producing countries have also plans to decarbonize. I don't know if I have more details for this slide, but most of the details are in the source that you can find when you have the slides.
Good. So I will take now a question from Arnaud Lambert. When you analyze the flying CO2 impact, you took only return flights from Luxembourg airports, but many flights are connected flights to long haul, Asia, US, Africa. Shouldn't you evolve the model to take this into consideration? So this is, of course, a question we had because we lack specific data about the number of kilometers that Luxembourgish residents do on average in the year. So there are two effects. Indeed, there are also connecting flights, so maybe we underestimated the impacts of flying, but there is another effect that could overestimate what we have done as a calculation, which is the fact that there are people living in France, Belgium, or Germany that go to Luxembourg airports to take a plane. So it's not Luxembourgish residents. So there are these two effects that compensate a bit each other. We don't know how much, and unfortunately, in the official report of greenhouse gas emission at the national level, the flying impacts are not considered. So we cannot really know what are the official flying impacts of Luxembourg. So this is our first approximation, and to really have a precise and representative results about flying impacts in Luxembourg, we will need to do a survey about that. And maybe this will be the case in the future, but we still do not have this data. And that's why we used the first destination from Luxembourg Airport as a proxy. And yes, of course, maybe we underestimated, maybe we overestimated the impact. We are not completely sure. So this is, I hope, an explanation to our calculation. So there is a question of Sasha, sorry for the name, Sichevich. I'm not sure how to pronounce, sorry. So scarce material might not be an issue for electric vehicle in the future. Do you have some information to share on research and development efforts in that domain? Paul or Thomas, do you have something to answer about that?
I can, and you can complement later if you want, Paul.
Yes.
So yeah, of course it's an issue, and the thing is that so far there's not much hindsight on the supply chain. For example, on the recycling of battery, there's all the signs indicate that it's indeed possible, but it's not at scale yet because there's still too little batteries that are at the end of life. So we might be able also to reuse what's being used today, but the question is probably also about the supply chains for these different materials. there's a lot of research going into or thinking about making batteries without these elements, so without lithium or without other materials, and that's actually one of the ways you can go towards not having this scarcity issue anymore. But there is also a lot of there's a lot of efforts into identifying sources of materials that are also let's say ethical. So the problem with scarce materials is also not it's of course that we might not have too much of it, but I don't think it's so true for so many of them. The problem right now is that there are also mined in areas that don't have I don't know, proper working ethics or that kind of things, and there's also a lot of indications towards having these problems solved by labeling, for example, batteries. There's some batteries that have an eco label, and controlling more the supply chain where they're coming from. But in terms of research, you can always go towards more efficiency and towards less and less materials, but in the end, as long as you use it, you will still have some impacts. So I'm not sure whether we will get rid completely of the question. Yeah. I don't know if you guys want to add.
Maybe just a small thing to add would be that it's not only about the materials themselves, but also the usage of the battery. Many batteries can be used post car, so you can use them after they have been in the car, which of course allows you to kind of share the carbon footprint among multiple usages of the battery, which sort of lowers the impact and uses those scarce resources more efficiently. And maybe there's also a question about circularity, which could be interesting in what regard you can design them in a way that you can easily reuse the batteries.
Okay, so there is a question of Etienne Jacques that maybe was partly answered. Let's see. You didn't mention e-fuels. What would be the results, especially if they were based on harvesting atmospheric CO2 and solar electricity? Batteries will not be practical for planes, so are e-fuels the solution? So I guess one of the answer was given by the projection here we have for 2030, so where our electricity will be cleaner and less based on fossil fuels. I don't know. So
yeah,
Paul or Thomas.
So I think right now to have I can take it quickly. To imagine flying without fossil fuels, there are two ways. It would be using e-fuels, which is using electricity and captured CO2 from the atmosphere to make fuels, or hydrogen from a decarbonized source. Of course, these are feasible technical solutions, and they could work technically on paper, but there's a lot of assumptions behind that that appear, I think, when you start thinking of scaling up the technologies. The problem is always that it would work, but it will also cost a lot of money, I think, and just to spread that technology will take a lot of time. And whether we should, because I think the question behind is then we should be able to continue flying. Sorry, I'm interpreting a bit, but the question is whether we should continue flying in the first place, because that's also another question about consumption, whether that should be the thing we should address first instead of thinking about technological solutions. And it's true that there are ways to do this, to make this possible. There is always the risk that we keep consuming as much behind, and probably that's also something we haven't touched much in the presentation. Maybe I'm a bit off track now.
Okay, so there is a question of Jeanne Pernon, so it's in French, I will translate in English. So does the certificate of guarantee of origins can reduce the climate change impact in Luxembourg? For example, if I have an electric car and I'm buying green electricity, do I have a real impact? So this is a question we also investigated a bit. So maybe just an introduction, there are different types of green electricity, and they mean different things. So in fact, the guarantee of origin will tell you that along the year, the electricity you consume was produced in the same year by green electricity, which is in fact renewable electricity in Europe. So there is a contract which is in Europe, or there are contracts that are more local, for example, in the great region of Luxembourg. And the carbon footprint you see on your green contract, they do not consider the life cycle impact. So sometimes with green contract, you will see 0 gram of CO2 equivalent per kilowatt hour. But in fact, when we use either solar power or wind power, the value is not really 0. It's maybe around 10 or 20 grams of CO2 equivalent per kilowatt hour. And there is also a physical meaning. So if you buy green electricity in the same region where you stand, the electricity that is produced from renewable electricity can for sure achieve your house. But when you buy it from Europe, for example, most of the green certificates in Luxembourg comes from Norway or Iceland. And in fact, the electricity network of Iceland, for example, is not connected to the one of Luxembourg. So there is also this debate of different types of green contracts for electricity. But of course, it can reduce the impact, your carbon footprint, especially if you are in a country where there is a high carbon footprint of electricity. Maybe Thomas, you want to add something about this explanation for
no,
green electricity?
The reason why it's not shown here, maybe also to add, is that in life cycle assessment, we usually don't consider statistical transfers, as they're called in the LCA. I know that you can actually buy green electricity in Luxembourg, but at least in this kind of studies, it's not taken into account. It is, if you do the carbon footprint of your company, for example, you have a way to take it into account in a separate way as the, so there's two ways. There's what they call the location-based and the market-based. And in the market-based accounting, you can take into account this electricity. But as Elorri said, it's true that it's so far a bit complicated, and I haven't seen, maybe some people in the audience know actually whether LCA has a strong opinion on taking into account green certificates. But for now, it's mostly what surrounds us, the amount of, so it's your production of the country adjusted with the trade with neighboring countries, and depending on what they produce, you will have a different consumption mix. Yeah, so there's actually a very close comment to that, is that, so Frank Minette says, in Luxembourg, nearly 100% of the households have green electricity, and several firms too. And this green electricity comes from and through Germany, as physically electricity comes by wire. It can only come from our direct neighbors, mostly from Germany, as electricity is not sent by Wi-Fi, but it's not the German electricity mix, CIL report. Yes, that's true, we know that, but it's also, what you see is that there's a lot of, it is also in the ILR, in the Institut Luxembourgeois de Régulation, one of their reports shows the origin of all the electricity that was in Luxembourg. And as Elorri said, most of it is actually Norway and Iceland, which physically cannot transfer all this, export all this electricity. For example, Norway has, in 2018, they have exported about 20 terawatt hours abroad to the EU, but they have produced 140 terawatt hours of guarantees of origin, which shows that there's a decorrelation between the market-based and the location-based approach, which both have their merits, but the problem is that in LCA, there's no strict standards, at least not in the ISO standards, to account for green certificates. But we are aware of this, yeah. It's actually, I think, a very interesting topic, but we can let that for another time.
Okay, so thank you. We are now at the end of this conference. Just before saying goodbye to you, I would like to remind you that on Thursday you will receive an email where you will find the link for the video of this webinar, also the presentation slides, and a survey to complete to evaluate this presentation. So it will be good if we receive your feedback so that we can improve for the next event. So thank you very much to all of you. Thank you to my colleagues Paul and Thomas. I hope you enjoyed, and we can also share about our next event on the 26th of January about our housing impacts. Thank you and goodbye.
Thanks everyone. Bye.
Thank you. Bye-bye.